All right, so the second part of our notes here is going to talk about actually doing these enlargements or reductions on the coordinate plane. So the first thing that we have to talk about is how do we actually do these enlargements and reductions? Like, what does it look like? So the first thing that we talked about with the dilation is with respect to a given point. So if we're starting off with an original image, let's just use a triangle, something like this. We're saying with respect to a given point, this is going to get, let's say, smaller. So let's say we reduce it by 1/2. So how this actually works, it's kind of cool. You trace a line through all of the points here. We take this here, and we are just tracing an imaginary line with respect to that original dot there, that original point, through all of the endpoints of this triangle. Some of these get pretty close to each other, as you can see. And once we've done this, this is actually how we recreate the smaller image. So we take this, and it goes something like this. So we use it to basically create a scale factor of the same shape, either going towards getting smaller or going away from getting larger from a given point. So if this is A, B, and C, we have our new image of A prime, B prime, and C prime of this being constructed. Now when we do this on the coordinate plane, we do this with respect to the origin. So instead of it just being a given point in space, now we do it, again, with respect to the origin. So we can make XY axis. And I can actually make these more accurate this time. Let's do that going up here. This would be the neatest graph I've done on a video. I'm using the ruler function. All right, and let's say we are given a shape in the coordinate plane. So something, I don't know, let's say like this. So this is what our shape is going to look like. And every move that we make is going to be with respect to the origin. So let's say in this case, our scale factor, and they're going to tell you this. So let's say we have a scale factor of, we'll call it maybe 2. That'll be easier. K equals 2. So how this works is you take all of your XY coordinates and you multiply them by 2. So it's like a rule. Like we've been doing these rules with rotations and reflections and all of those things. So now instead of changing the signs of them, we're going to multiply the X and the Y coordinates by the scale factor. So here we have -1, -1. If we're going to take this point A and reflect it, so if A is -1, -1, A prime would be 2 times -1, 2 times -1. Or if we fully solve that, it would be -2, -2. So we can go ahead and actually rewrite that point. So we go left 2 and we go down 2. So here is the image of A. And then we would continue to do that actually for all of our points here. So we would basically just go through one at a time for every single one of those XY coordinates. So we'll keep going. Let's say that this one here is B, and this B value is -3, -1. So we're going to take B now, of -3, -1, and multiply each of those by 2. So our b prime coordinate is going to be -6, comma -2. So now let's do this here in blue. We'll go 6 left, 1, 2, 3, 4, 5, 6, and then we'll go down 2. And then we're going to keep doing that for each of our points. Then eventually we're going to see this reflected shape. So let's keep going. We'll do C. In this case, C is -1, comma +3. So C prime is going to be -1 times 2, and then +3 times 2. So we'll get -2, comma 6 for our C prime. So -2 up 1, 2, 3, 4, 5, 6. Go up a little bit higher actually than the graph here. So somewhere up here. And then for our last point, we'll call this D. D is -3, comma 2. So that'll be the final thing that we do. So in this case, -3 times 2, comma 2 times 2. So our reflected point of D is -6, comma 4. So go 6 to the left, and actually this time only up 4, and that'll be our D coordinate, the image of D. And if you see, what we've just drawn here is just a larger version of the same shape. And the kind of neat thing about this is it is reflected along the origin. So remember those points that we initially drew before, and you won't need to draw these in for your answers, but we can see, this is kind of neat here, that all of these points have just been dilated with respect to the origin. They all go through each other. Your B and the image of B, again, they're going to intersect through the origin. So kind of neat how this works. It's almost like a spider web, just like shooting out of the origin with all those points there. So I'd say the basic framework for this is, one, finding the scale factor. So our formula for scale factor was new over old. And then second, if you're given the scale factor on the xy axis, how this is going to work is you're going to take your scale factor, which is k, and your new ordered pair is just the original x comma y, except we're going to multiply each of these by k. And those are going to be the two skills that you need for today. So the second video here is mostly going over calculating those ordered pairs. And then for the first video, that's mostly going over identifying scale factor and seeing, is it getting bigger or smaller? So again, after finishing up today, we should have some of these scale factor drawings in there. And most specifically, we should have some of these final answers as ordered pairs that we calculate.